alive.
You didn't need to do
All right, so in this chapter, we are going to be starting trigonometry, but before we do that, we're going to look at geometric mean. You'll notice on the lesson plans that I gave to you, you need to have a calculator for this chapter, okay? No cell phones will be allowed. You shouldn't be using them in class anyway. You know, Roni. So we need to have the calculator because we're going to be using certain buttons on the calculator. They're called the sine, cosine, and tangent.
Special buttons with the letters? I don't like this one.
Stop talking. So, yeah, those are the buttons that we will need for this section. Okay, so in chapter 8, we're going to start with geometric mean. All right, so in algebra, you usually learn about arithmetic mean, or just thinking about what does it mean to take the mean of the numbers. That's the average. Okay, so geometric mean involves a proportion. I think it's just erased.
Oopsie.
Okay, so geometric mean is a proportion of, if we have a to x, then that's going to be the same as x to b. And I'll show you later on the right triangle where we get that proportion. So if you cross multiply, you get x squared is equal to ab. So the geometric mean is found by taking the square root of the product of the two numbers. Okay. So if we have 4 and 9, so you could set up the proportion. So x is the geometric mean, and you'll see why I'm going to set up the proportion like this. You can go right to the answer. You could go right to taking the product of the two numbers and then taking the square root. But I'm going to set it up like this because I'm going to use proportions later on. So whenever you hear something is the geometric mean, so x is the geometric mean, we put it, as long as they are diagonal to each other, okay, and then you put the other two numbers in the other spots, and then we cross multiply. We get x squared equals 36. So when we take the square root, what do we get? Yeah, and there we go. Now, one of the things, when we usually take square roots, we would get positive or negative numbers, but one of the conditions on geometric mean is it has to be positive. Okay, so right here it says it's a positive number. So it's never going to be a negative value. Okay, 6 and 15. So again, x is the geometric mean of 6 and 15. What's that, Ronnie? You can skip to the multiplying and then the square root. There's a reason I'm stressing this approach, and that is when we do triangles later on. You'll say we have some rules about geometric mean. So basically what I'm saying, whenever you know, so when I say x is the geometric mean, I know that I have to have it diagonal to each other, and then the other two values go in the other two spots. Do you have to show all of this? No, but you'll see later why I'm using this approach.
Are we not, for this one, does it matter if we like square it in a calculator, or do we have to take it out?
Okay, so when it says simplify each answer, simplify means that we want to reduce the radicals. So we don't want to have decimals. So no decimals for these answers. I want to have them in what we call simplified form. Now, when we go to take the square root here, what do we get? So 90 is 9 times 10, so we done? 3 root 10. All right, any questions there? All right, 6 2/3. 6 2/3, we're gonna, so we have 6 times 2/3. What do we get when we multiply 6 times 2/3? 4? Yeah, it's 4. So x equals, right, when we take the square root, we just get 2. And finally, if we have x in here and here, 10 and 15, so x squared equals 150. What happens when we take the square root for 150? Raise your hand if you have that one. Go ahead, Don. 5 root 6. Right, because 150 is divisible by 25, so we can take the square root of 25 is 5, left over with the square root is 6. Are you okay with that, or do you need to see? You can also do the factor tree. It just, takes some time. Okay, any questions? All right, so now we want to use that idea of geometric mean. We're going to look at specifically right triangles. So this whole chapter is on right triangles. We're going to learn about trigonometry. Trigonometry just means, so the first part, triangle, okay. And the last part of the word,
Trigonometry?
no, metry,
Met.
so it means
Meter?
measure. So it's looking at the measures within triangles. Okay. So here in theorem 8, if we have an altitude, that is drawn from the vertex of the right angle. So you have a right triangle to begin with, right? So ABC is a right triangle. Here's the right angle. And then if we draw the altitude from the right angle, that makes sense. So we're drawing it from the right angle to the hypotenuse. Right here, AB is the hypotenuse, right? How do we know which one is the hypotenuse?
The longest side.
Okay, so the longest side is the one that's opposite the right angle. So what happens here is that we have 2 smaller right triangles that have been formed. Do you see that? Angle 3 and angle 4 are both right angles. So what happens with these 2 triangles is that they end up being similar to one another and to the original. So why? Why are they all similar to each other? Okay, so they all have a right angle. So there's a right angle here, right angle here, right angle here. So each one of them, they share one pair of congruent angles. But what else?
They all share a side.
Okay, so the side that they share, though, isn't necessarily, we're saying that they're similar, not necessarily congruent,
The angles.
the angles. So for example, if we look at this triangle here, the small one, this shares angle B with the large triangle. So by angle-angle similarity, we know that the big triangle ABC is similar to, how would we rate the letters in what order for that small triangle there, Roni? C, B, D. Because C, this angle 2 right here, actually corresponds to angle A. B corresponds to itself, angle B. And then notice angle C on the big triangle here is the right angle, and angle D is the right angle in the small one. Everybody see that? Question?
It was confusing on the test, just looking at which side of the small triangle was the same as the bigger triangle.
So that was one of the hints that I gave to you, is that you might want to draw them separate. Who was I looking at? Was that your test, Brittany, that you had drawn them separate?
Yeah, and then,
it was like angle, whatever the letter was, and it was like angle E and angle E. But you have to remember angle E is the same angle.
And then I
So
still
in
don't
this
like
one, it's
them.
angle B. Angle B, they both share.
Oh.
Do you see it? So they both have a right angle, and then they both share an angle. You see it now? All right, let's look at, there's another triangle that's going to be similar. Actually, let me erase the markings here. And now let's look at this triangle. So if we look at that triangle and compare it, let's compare it to triangle ABC. So obviously they both have a right angle. Angle 3 is a right angle, and then that angle C up top is a right angle. What angle do they both share? Angle A. Do we see that? So by angle similarity, this triangle that I traced in red is going to be similar to the big triangle. So therefore, this triangle is similar to the small one, and they're all similar to the original. What order do we need to put the letters, though? Okay, so for this triangle with A and C and D, what order would we put them in? What would it be?
ACD.
ACD. All right. Okay with that? Questions? All right. So now we get into the applications of what happens when we have that altitude drawn. So when we have that altitude that's drawn from the vertex of the right angle, so this altitude, that would be CD, okay, is the geometric mean between the measures of the two segments of the hypotenuse. So what would that look like as a proportion? So this is where I said, as soon as you see something is listed as the geometric mean, this is the altitude, right? So that altitude, we write twice. So whatever is the geometric mean, that's where we put them in these two spots. Of what? Of the two segments that make up the hypotenuse. What are the two segments? One of them is AD, and the other one is DB. Yeah, you done? The altitude is always the geometric mean. If it's, okay, you have to have a right triangle to start. Then when you draw that altitude is always the geometric mean of these two segments that make up the hypotenuse of the original. Why? Well, if we go back to this picture, we can use triangle similarity to create a proportion. Do you see it? Here's CD. CD is to AD. Right? So you can kind of compare that you have proportional sides within those three similar triangles. Questions? So do you have to really remember this theorem? No, not necessarily. As long as you can remember what you learned in the previous chapter and that you know sides have to be proportional to each other in similar triangles, you could just look at, okay, so I know, this is kind of a shortcut. All right? So I'll write it out like this. Let's write it out in words. So the altitude would go here. And then we put one segment of hypotenuse. And then the second part. So put the altitude in those two spots. You take one segment of the hypotenuse and then the second segment of the hypotenuse and multiply those together. Okay, so let's look at this example. So in PQR, RS is 3 and QS is 14. So PS, let's say that's x. That's what I'm looking for. So what is the geometric mean? It's the altitude. So the altitude is x, is the geometric mean between 3 and 14. Does that make sense how I said that, the proportion? Okay, so when we cross multiply, we get x squared. What's 3 times 14? 42. And when we take square root, can 42 be broken down into
No.
having any perfect squares? No. So we can just leave it as square root of 42. Oh, actually, we should probably write EX. Okay. Questions? All right, take a look at the next two problems. Does somebody want to come up and do A? You done? Anybody want to do B? Romy? I saw both of you guys said you. Unfortunately, we have to do it on the board this time. I can use the tablet, but for some reason when I'm recording, it makes too much noise when you're writing on it. Like beeps and sorry. There. There, just erase the line. Try it over. I'm thinking maybe if you write not so. Is it still not working? Here, let me see. And then, okay, now go. Good. So 2, 3, 3.
That is.
Okay, Roni, let's go. Thank you. Ben.
Well, it's based on the.
Yeah, it is. But it's such a good show.
The book sucks.
I haven't heard of it. It's like a government thing.
It happens. I don't know. They probably were searching for you and you didn't.
Oh, it's the room number.
Yeah.
That's what I'm going to say.
Ronnie, you're not done.
Sorry.
All right.
It's fine, I'll put myself.
So in terms of
Pay back to myself.
Ronnie? Yeah.
okay, oh, this is a 4 root 3. That's good. Thank you.
And more.
All right, everybody has that?
Yeah, man.
Go ahead. Okay, we have another theorem.
We do?
We do.
Algebra.
Last one for this section. All right, so this next theorem also pertains to the same diagram where you have a right triangle and you have the altitude drawn from the right angle. Okay, so this one is a little more complicated. So let's take a look at what it says. If we have this case where the altitude is drawn to the hypotenuse of the right triangle, then the measure of a leg of the triangle. Okay, now what are the legs? We're talking about the original triangle ABC. What would be the legs?
ABC.
No.
AC.
There's only 2 legs.
AC and BC.
Oh.
Okay, so this is a leg here, and this is a leg. Right, we already said that this whole thing here.
We don't mention the devil.
It's because you guys have 2 legs.
So every right triangle has two legs. So the
Like
legs
us.
are the ones that make that when they intersect at the right angle. So the hypotenuse is the one directly across from the right angle. Again, we're looking at the original triangle. Don't worry about the smaller ones. So the measure of a leg, so a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. So that's why I said it sounds a little confusing when you look at it in words. So that's why we have everything labeled with different variables here. Okay, so each leg is the geometric mean. So,
Wait, so they're the
Say
X's.
wow.
okay, you have to take the leg, take one leg, take the same leg. We're going to put that in these two spots. Then over here, yeah, it's going to work for both of them. So I'm going to show you both. I'm going to show you both proportions. There's two proportions for this one. So then you're going to take the entire hypotenuse, and then this part is the part of the hypotenuse that's adjacent to the leg.
Wait, what's the geometric?
You just
Were you busy with the calculator?
Jacob bugged my calculator. Jacob bugged his own calculator.
I got it. So okay, if the leg
Okay.
I get it.
Then it'll be you like hypotenuse equals c and the part of the hypotenuse will only be y.
Right. So let's look at A. So looking at this side A, which is one leg of the original right triangle. So we put A here and A here. Now the entire hypotenuse, that is C. And then we need just the part of the hypotenuse that is adjacent to the leg. So here's A. It's going to be Y.
So there's
Okay.
two variables. So there's three variables.
I'm just showing you how to set it up.
Yeah.
We'll set it up for the next one. Okay, the other one, Sarah Gleason.
Wait, I have a question.
Yeah.
Does it matter which one?
No, it all depends on what you're looking for. So
Yeah, it
here's,
doesn't matter which leg. Like,
I use my right leg.
okay, I'm going to look at the other one now. So now I'm looking at B. So B would go here and here. Well, the hypotenuse is still C, so I'm going to keep that here. And then if I look at side B, so here's B. The segment adjacent to that would be X.
What if it doesn't give you? Wait, never mind.
Adjacent means that they have to be, right, they have to be touching, they have to intersect at that one point. And it has to be part of the hypotenuse. Okay, so we don't have a geometric mean with one leg and the other leg. Yeah.
I'm still a little confused with the first one, the C over A. Wouldn't it be like Y? Isn't it Y though? Oh no, Y is
The entire hypotenuse is C.
Oh.
Why do we use C and X on the second?
Because X is adjacent to B. Whereas over here, A and Y are adjacent to each other. So when we use, it depends on which leg we're referring to, will determine which segment we want from the hypotenuse. So if
Wait,
this,
can it not be the altitude? 'Cause can't.
no, it says right here, the segment of the hypotenuse.
So what if you need to find the altitude?
If you have to find the altitude, you use the previous geometric mean here. Okay?
It's so complicated.
I suddenly understand.
Okay, it sounds worse than it is. When you guys go to solve these, and then you'll see that you can use proportional parts. So you could do similar triangles. We'll have geometric mean, and then later on we'll also, even though Pythagorean theorem you've learned before, we'll also have a lesson on that in this chapter. So let's look at this problem where we want to find x and y. So in one case, x is an altitude. So this is an altitude. and this is a leg. So the way that we're going to set up, I'm going to use geometric mean for both of them. However, you may see that you can also use Pythagorean theorem to complete one, but because we're doing geometric mean, I want to practice that approach. So do we have enough information to, we could solve for x or for y first. So Danielle?
I think I'll also do y first.
Oh, that's fine.
Oh.
Go ahead.
Okay. 11 over y equals y over 3.
Good. So the leg is y. So that's why we put the y here in these two parts. The leg is the geometric mean of the hypotenuse. The whole thing is 11. And the segment adjacent to that leg is 3. Okay, so Danielle, we get?
Y squared equals 33 Pythagorean
And y is square root.
Yeah.
33. Okay, questions on that one? Okay, can somebody give me the setup for the
8
altitude?
over x.
Um,
You can do it.
No, no.
Okay.
No, I don't want to do it.
Brittany, just say it. Just say it.
So 8 over x equals x.
Good. So this time the altitude is the geometric mean of the two segments that make up the hypotenuse. So Brittany, we get x squared equals, so x equals,
2
good.
Wait, I
Wait, so
don't understand
lab?
what y was. We're solving for the, why did we solve for x? That's, so we're solving for one leg and then the hypotenuse?
Okay, so we could have solved for x first, or we could have solved for y. It doesn't matter which one we solve for first.
So we solve for one of the legs and then, and the hypotenuse. That's what we solved. You don't, so that's.
What are you saying?
Which hypotenuse? What do you mean? Okay, so there's more than one way to do this problem. In this particular problem, you have to find one of them first. So you could have found x, and then notice that you have a right triangle here. So you could have done Pythagorean theorem. X squared plus 3 squared equals y squared, right? Because if this is a right angle here, then you can use Pythagorean theorem. But again, I was showing you how to use geometric mean with each part. You could also have found out what y was, and then also. So you have to use geometric mean or proportions to solve for one of them first. You have to. And then you could use geometric mean a second time, or you could do Pythagorean theorem. Let's look at the next one, because this one is a little different. We don't have enough information to find y first. Why not?
Because then
Why
I
not?
ended up with
Okay.
2x, which x squared equals y squared.
Okay,
got this.
so we don't know what x is, so we can't figure out what the
Solve for
hypotenuse.
x and then you
Because
can stop.
this is the leg, and in order to use the geometric mean with the leg, we need to know the hypotenuse and the segment adjacent to the leg. So we have too many variables involved, which means I need to figure out what x is equal to first. So in this case, I'm actually given the altitude. So I'm going to put the 2 root 3 here and here, because that's the one that is the geometric mean of the two segments that create the hypotenuse, that make up the hypotenuse. That's going to be x and 2. Now, when you multiply 2 root 3 times itself,
Why do you do x plus 2 for on top of first and then?
no, the altitude, the first theorem that we looked at,
Wouldn't it be 4 root?
right here, this one,
Wouldn't it be 4 root 3?
the altitude goes here and here, and then you take one segment of the hypotenuse and the second segment of the hypotenuse.
Wouldn't it be 4 root
Okay, just a minute. Okay, so when we multiply these, I'm gonna write out the steps just so we can remember. When you multiply things that have radical and numbers outside, it's kind of like you multiply the stuff on the outside. So like the 2 times 2 would give us 4. And what would be root 3 times root 3?
Root 9.
Root 9, which is,
And then you get 6.
right, so we get 12
Hopefully.
here, divide by 2, so we get 6. Okay, now that I know that this is 6, we can go back and solve for y. So raise your hand if you have that proportion, Joshie.
5 over y is equal to y over 3.
What?
Okay, wait. What's the hypotenuse?
8.
Oh, sorry, 8.
8. And what do we put underneath here?
6.
6, perfect. So we have y squared equals 48. So y equals, and we had square root of 48 earlier, which was 4 root 3. Now, your book may have decimal answers in the back. It's fine if you want to do a decimal approximation, but I will tell you on the test, I want most of the answers to be in simplified radical form, because that's how you're going to have to write most of your answers when you get to Algebra 2. So I want you guys to have the practice.
No, this is not true.
I know that. Do we do stuff like this in algebra?
No, geometric mean is usually something just that you will see in geometry. Josh,
Maybe
Reagan?
we score
I'm
with
still a
this.
little confused with all this, like how to put it together.
Okay, so it comes from, it depends, see, and that's where you have to look at what do you know, what information do you know, and what do you need to find.
So if it's
So,
like a
like-
variable instead of a number, you pick the number that's adjacent.
I'm gonna be
Well,
simple.
yeah, I mean, okay, so sometimes, in this particular case, I know what the altitude is. I don't know what the legs are. And I know that the two segments that make up the hypotenuse are 6x and x.
So y'all be getting some crazy afternoons.
Okay. What do I have to, do I have enough information? Okay, so thinking about geometric mean. Do I have enough information to solve for one of the legs first? No. Okay, so I can use the one with the altitude because I have these two segments are the same variable, have the same variable involved. So I know, again, it's helpful if you just memorize the theorem. What is the geometric mean? The altitude is the geometric mean, so the altitude is what we write twice, here and here.
That's a big number.
Is the geometric mean of the two segments that make up the hypotenuse. So we're going to have 6x and x. You understand how I set that up?
I got that right.
Okay, so cross multiply, we get 6x squared.
1,296.
Radical
Can you
6 is
divide by
216 and that's 6 radical 6.
216, take the square root, and we get 6 root 6.
14.69693.
All right, that was x. So now, once we know that this is what x is equal to, so this is 6 root 6. And then this one, what would this one be? 36 root 6. It's okay.
We still know what it is.
You guys know what it is. So now I can solve for y, or I can solve for z.
You do both.
Okay, well, you want to do y?
Now let's go x, y.
So we have y is the geometric mean of what?
36,
No, it's the whole thing.
6
It's-
plus,
it's-
I was saying
it's
36 radical
36
6 plus 6 radical 6, that's what I was saying. But why did you do that?
Because fraud is just like a
Okay, when I
abbreviation.
combine, so
Don't
because
add the inside.
when I combine radicals, you have to think of them as adding like terms. So 36 plus 6 is 42 root 6. You add radicals just like terms. So if it was 36x plus 6x, you would get 42x. Think of the radical as your like term.
Yeah.
They have to be the same. If this was root 6 and this one was root 3, we could not combine them.
So it's like a variable?
It's like a variable. All right, so now we have 42 root 6 because that's the entire hypotenuse. What segment from the hypotenuse is adjacent to y? It would be 6 root 6. All right, so I get y squared. Now 42 root 6 times 6 root 6.
352
And you guys,
radical 6.
something like this, you could multiply this on your calculator and it will give you a whole number because your calculator will know that when you multiply those together, you just get 6. So whatever 42 times 6 is on the outside, and then multiply that by 6. Ari, you said, what was it? Did you have it?
I got 252.
No, when you
Multiply
multiply
with
with it.
equal.
Oh, when you don't, oh, I didn't do that yet.
Oh.
It's gonna be
15,
wait,
12.
no, it's
So we get what for the final?
I don't know.
I got arms over there.
It is.
I don't want to just-
Okay, guys, look at the beginning here. This gave us a 6. There's a 6 here, and can you divide it by 36?
Yeah.
Divide it by 36. What do you get? Divide 15, 12.
Wait, couldn't you just do 252 radical 36 and simplify that?
There you go.
Yeah, that's what I said. You have a 36, root 36, divide 6 here, 6 here, 6 here.
Now we're gonna do 9.
No?
But you didn't do 252. Like that's how you, that's 42 times. Whatever.
Yeah, we'll do 0 right now.
Okay, one more.
Z.
Z goes here and here. So this one's just a really big number then.
Oh, wait, we know what that is. It's 115, 12.
Wait, hold on a second.
It's 15, 12,
Wait,
root
can we
36.
explain why it was 36 root 6 for that part?
Because that was the other part of the.
That's the other part of the hypotenuse right here.
Oh, okay, yeah. 7.
How did the 36 start to school 7 so fast?
Because I knew the answer.
12 and 6.
Math genius.